Welcome to lecture 12. So, we are now talking about performance characteristics of instruments and data analysis part 2. So, in this lecture we will talk about types of different errors that are associated with your measurements. So, today's topic types of error in measurement, and also we will introduce some basic statistical concepts. Types of errors in measurements can be broadly categorized in three groups: gross error or human error, systematic error or determinate error, and random error. Gross error or human error is caused by human mistakes. This may happen due to wrong reading, bad or wrong using of instruments. This cannot be eliminated completely, but can be minimized by taking care and proper usage of instruments. Systematic or determinate error. Systematic error affect all the readings in a particular fashion. So, they are systematic in nature. They are also deterministic, that is why determinate. This is caused due to shortcomings of the instrument, such as defective or worn parts, improper design of instrument, loading effect, etc. When determined, systematic error can be corrected by careful calibration of the instrument. That is why we call it determinate error. Systematic or determinate error may be of a constant or proportional nature. When it is proportional in nature, it influences the slope. Constant error influences the intercept. Systematic or determinate error are mainly three types: instrumental error, environmental error, and observational error. Instrumental error is inherent in measuring instruments because of their mechanical structure, such as bearing friction, irregular spring tension, stretching of spring, etc. Instrumental error can be avoided by selecting a suitable instrument for the particular measurement application, applying a suitable correction factor by determining instrumental error, and calibrating the instrument frequently against known standard. Environmental error is caused due to external condition affecting the measurement, such as change in temperature, humidity, barometric pressure, etc. To avoid the environmental error, provide suitable environment for the instrument, seal certain component in the instrument. That means, if some component of the instruments are sensitive to, say, temperature, we put that component in a sealed environment to isolate it from the effect of environment. Observational error, this is introduced by the observer or the user or the operator of the instrument. Most common is parallax error and estimation error while reading the scale. Random error is due to unknown causes. Random error can be avoided by increasing number of readings. So, you take more number of readings and use statistical means to obtain best approximation of true value. Now, let us talk about uncertainty associated with measurement. All measurements have some degree of uncertainty that may have come from variety of sources. The complete statement of a measured value should include an estimate of the level of confidence associated with the value. So, measurement is best estimate plus minus some uncertainty. Measures of central tendency of data. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. Imagine you have taken an instrument and you are measuring a quantity several times. So, you have a set of data. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. Most commonly we use mean, maybe arithmetic mean, median and mode. So, we will now define what we mean by mean, median and mode. Arithmetic mean is equal to the sum of all the values in the data set divided by the number of values in the data set. So, I have taken n observations or n readings, those values are x 1, x 2, so on and so forth up to x n. So, the arithmetic mean is simply sum of all these values, sum of n readings divided by n, which represents the number of readings taken. So, arithmetic mean is can be written as x I equal to 1 to n here and n. Now, we can also have weighted mean. Weighted mean is defined as this. So, we give certain weightage to each observation and let us consider those weights are W 1, W 2, W 3, W n etcetera. So, W 1 is associated, W 1 is the weight associated with observation x 1, W 2 is the weight associated with observation x 2 and so on and so forth. So, weighted mean is defined as W 1 S 1, W 1 x 1 plus W 2 x 2 up to W n x n divided by W 1 W 2 up to W n. So, you can write as sigma W I x I equal to 1 to n divided by I equal to 1 to n W I. So, this is weighted mean. Next is median. The median is defined as the middle value of a group of data arranged in order of magnitude. So, you have a set of data, you have taken, let us say you have taken a pressure measuring instrument and you have measured a given pressure several times. So, you have a set of data. Now, you arrange this data in order. Now, the median is the middle value of this arranged data. So, median is defined as the middle value of a group of data arranged in order of magnitude. Now, depending on the number of observations that you have taken, you can have an exact midpoint. Like say you have taken 11 readings, you have taken 11 readings. So, in that case, sixth one is the midpoint. So, 5 readings above 6, 5 readings below 6. So, 6 is the midpoint, 6 is the median. But let us say I have taken 10 reading, then I have to take average of 5 and 6 as median. So, when n is odd, your median will be given by this, and when n is even, it will be given by this. So, when my n is 11, so number of observations is 11, median is n plus 1 by 2, that means 11 plus 1 by 2, that is the sixth data, 6 from the top, they are all arranged in order of magnitude. N is odd, so you get the sixth one. If n is 10, it is even, so we said that it has to be average of 5 and 6. So, half n by 2, 10 by 2 plus 10 by 2 plus 1, 10 by 2 plus 1. So, half 5 plus 6 . So, I think there is some problem here. So, it will be n is even. So, 10 it will be 4 top, another 4 below, you have 5 and 6. So, this average of 5 and 6. So, 5 and 6, average of 5 and 6, this is fine, no problem here, this is fine, average of 5 and 6, average of fifth and sixth value. So, this is correct, this is correct. We have to calculate median depending on whether the number of observations is even or odd accordingly. Mode, the mode of a set of data is the value that appears most frequently. The mode of a set of data is the value that appears most frequently. Now, if I have several observations and then I make a frequency plot like this. So, basically you plot observations, those values versus frequency, and if I get a curve like this, this is the value that happens most frequently. So, this is the mode of this set of data. It is not necessary that there will be only one mode. If there is only one mode, we call it unimodal. If the plot is like this, frequency versus observations, you have one mode here, you have another mode here. So, this is known as bimodal distribution. if you have a symmetric distribution like this, your mean, mode and median will all be same, because if you have a symmetric distribution, this is mean, this is mode as well, and this is median as well. But if you have instead a skewed distribution, that means the distribution is not symmetric, it is skewed, it is called left skewed here, you can also have right skewed, then this is mode, because this is the value that you encounter most frequently, but mean may be this and the median, this is mean, and mode median may be this. So, mean, median and mode may all be different. Mean, median and mode are same only for a symmetric distribution, but distributions which are not symmetric, the mean, median, mode may all be different. Measures of dispersion or spread of variability. Range is the difference between the maximum and minimum values of the given data. We have talked about this when we talked about static characteristics. So, if I take range to discuss the measure of dispersion or the spread of variability, that is how the data is distributed or how the data is spread, one can use the definition of range, which is the difference between the maximum value and minimum value of the given data. But this is based solely on the dispersion of the extreme values, extreme high and extreme low. Average or mean deviation, this is a better estimate of measure of dispersion or spread of variation or spread of variability. Average or mean deviation evaluates the average of the absolute value of the deviation of each data point from the arithmetic mean. So, average or mean deviation evaluates the average of the absolute value of the deviation of each data point from the arithmetic mean. You have n data points. So, you find out the absolute difference from each observation from the mean, which is represented as this, and sum those differences and then divide by n minus 1 to get average or mean deviation. Variance, it is the mean square deviation of the given data. Look at the expression for variance and look at the expression for the average or mean deviation. So, variance is the mean square deviations of the given data. So, you have found out the difference of the observation from the mean, difference of each observation from mean, square them, sum them up and divide by n minus 1, where capital N is the number of the observation. Standard deviation is just the square root of the variance. So, this is the expression for variance, square root of this is the expression for standard deviation. Coefficient of variation, the coefficient of variation presents the degree of scatter of the data with respect to the mean value. So, the coefficient of variation represents the degree of scatter of data with respect to mean value. So, this is ratio of sigma to mean value. Sigma or standard deviation is given by this. So, you divide sigma by mean value of the data set. So, you get coefficient of variation. Please note that the coefficient of variation will not be useful when mean is very close to 0. So, if you have a distribution like this on one hand, and if you have a distribution like this on other hand, here you see that the spread of the data around mean or the scatter of data around mean is low. Here the spread or scatter of data around mean is high. So, the coefficient of variation is low here, the coefficient of variation is high here. Here most of the data are centered around mean, here most of the data are not centered around mean. So, this is how we estimate or represent the uncertainty. We use standard error. If x n bar is the mean of the sample data and u n is the best estimate of internal uncertainty, we will represent the measured data as mean plus minus best estimate of uncertainty. So, x is x bar plus minus u, and an estimate of this uncertainty is standard deviation. This is standard deviation divided by square root of n, where n is the number of observation. So, an estimate of standard error or uncertainty is standard deviation divided by square root of number of observations, and then the measured value will be expressed as mean value plus minus this u n, which is the best estimate of the internal uncertainty, can be represented as standard deviation divided by square root of number of observations. So, we will stop our lecture 12 here.